Alright, so in this video I want to take a look at the difference between elements and compounds. And these are two words that a good chemist knows the difference between. And at the chemistry party later in the year, these are going to come in handy for you. So let's go through and kind of take a quick tour of the difference between elements and compounds. So first of all, an element. The periodic table of elements, which is a chart that's on the wall of our room, something like this. An element is one of the 92 naturally occurring particles that occur in nature. So anywhere on this periodic table, if you were to point at something, for example, we've got, say, carbon, C is here. Iron, Fe, is somewhere here. Sodium, Na, is over on this side. Anything that appears on this periodic table is an element. So we can define an element as we can say smallest particle of matter. And if you think of Lego blocks, a single Lego block would be like an element. Right? You can build other things from those single Lego blocks, just like you can build things from the elements. Now, elements almost always exist in a particle called an atom. An atom is a single particle. So, for example, we could have an iron atom, so it would be just one Fe particle. Now, a piece of iron that you might have in your house, or some rust, sorry, not rust, rust is a compound. A piece of iron will have countless numbers of these particles. They're very small. So we have elements, the smallest particle of matter, and they consist of atoms. Let's look at a compound. What is a compound? Well, a compound is two or more elements combined. So when we think of a compound, one of the more common ones is water, right? You probably know that water is H2O. That means it's two H's and attached to an O. So a water compound is made up of three atoms. Sodium chloride is Na. It's an Na atom attached to a Cl atom. It has two atoms. Now, a single particle of a compound can have one of two names. So, a single atom of a compound, let's do compound, a single particle is called almost always a molecule. So we would say we have one molecule of water, or one molecule of sugar. And for now, that will suffice. So a single particle of a compound is called a molecule. Now, I want you to take note of this, that some atoms, I need to say some elements, smallest particle is a two atom particle. For example, so an element, so let's look at oxygen. Oxygen in nature does not exist as just a single O particle. It actually exists as two O particles. So this technically is what's called a diatomic molecule. And what that means is it's an element. Oxygen is an element, but it exists in nature as a two-atom particle. There are 7 of these that you should know. I'm going to write this down. If you can remember this name, Mr. Brinkelhoff. So Mr. Brinkelhoff tells you the 7 atoms that you need to remember that exist as a diatomic molecule. Br, iodine, N, nitrogen, Cl, chlorine, hydrogen H, oxygen O, and fluorine F. All of these exist. So fluorine would look like this in nature. It would be two fluorine atoms together. You rarely ever see these 7 in a single atom. They always exist as a pair of atoms.